And the risk, the loss of crew, because of the EDL risks, I think we can achieve some significant improvement there too. And certainly, that's always going to be one of the things that in the trade studies, in order to get somebody to say, yeah, we can go, you got to be able to convince them that it's not such a high-risk thing. So that's a big contributor. The third one, the use of the moon. Well, that was a topic we heard a lot of debate about earlier today, and I think it makes going there mean something, because if you do this and you go there, not only are you going to have the advantages of all the other hardware experience and things like that we talked about, people have been talking about with Constellation, but you can make something there that's actually useful for going to Mars. And it's a piece of the overall plan for getting to Mars and staying. And it is an evolutionary method. I mean, I think that's one of the other big things that we've got to look at is break stuff down. One of the lessons we learned out of electric propulsion development was when I was working on MPE thrusters, when other people had been working on ion engines for years and years, we couldn't get them flying. The thing that flew, the very first electric thruster that flew for us in 1983 was a hydrazine resistojet, because it used the same propellant that the satellite already had on board. It didn't need much power. It fit. So you got to take those little baby steps. And then once we did that, then we worked up the hydrazine arc jets, and now we're flying hall thrusters and ion engines. So it's sort of breaking them down a little bit at a time. You take what you can get, and then you wedge yourself in and you go a little further. And then the last thing is it gives us the opportunity for international cooperation. That came up a little bit in some of the questions last time, but I'll show you the idea of the roadmap here. And I think all of these are things that are going to be, considered. What they're looking for right now and these options that they're asking about, some of these are very important things. And so the technologies that we need, definitely nuclear power. I don't think you're going to go out away from the sun without nuclear power. And bases, there's so many issues with surface power. You heard the Spirit and Opportunity talk the other night about the dust issue. And you've always got the issue of just the seasonal variation. So nuclear power is the way to go. I'd like to see us develop a nuclear thermal rocket, because it is a good way to get crew out there. It will get you there reliably at a high ISP, about 800 seconds, 800 to 900 seconds, which is about double what we can do with hydrogen oxygen. We need to scale up the hall thruster technology, but really that's what it is. It's a scale up. There, that stuff works. It's a very nice thruster. ISRU technology would be developed for this, both at the moon levels and Martian surface. And again, the idea is you could do this in you could do a sample return in this way and demonstrate some of the ISRU technology before you actually go to this full-scale mission. You look at propellant transfer and storage in space. I think the depot guys, they're pushing that too. You look at crew habitats, environmental control, and surface mobility. All those are common anyway. But in terms of me being a propulsion guy, you see all the top stuff's all propulsion stuff, right? So here's the roadmap. How do we get there from here? Okay, start today. 10-year development. That's all real stuff right there. That's a one EDLV launch to get that up there, and then cargo comes up in whatever launch vehicle you want to bring it up and docks in Earth orbit, and you fly a round trip to the moon in a year. Drop the cargo off, come back, fly another round trip. So basically you got a tug a year that can go back and forth to the moon. You build a couple tugs, you got a tug every 6 months. You build, you can figure the math, but you can start running a railroad back and forth to the moon. And with you're talking about an ISP now on those hall thrusters of 3,000 seconds. And I'm not talking about something that's working in the lab. I'm talking about something that's flying on spacecraft right now. So you got a way to get back and forth to the moon. Do some ISRU technology development about that same time frame. You could go do that demo on the moon. and by the way, you see the flags. This is our international partnerships. I was part of a delegation over to Russia in 2006. They've got tremendous interest and tremendous facilities sitting there for doing reactor development, for both the reactor itself and for nuclear rocket technology. They didn't shut their program down as early as we did, so their facilities are in better shape than ours. Ours out in Nevada are kind of starting to fall apart. So anyway, really interesting things you can do. ESA, I mentioned earlier, they've already flown Smart 1 to the moon. They're very interested in solar electric propulsion. They'd be a nice partner there. The Japanese, somebody mentioned earlier, anything to do with making propellant on the moon, doing construction on the moon, you can get Japan to help with that. You got the propellant storage and transfer development. You're going to do these depots in space. You got to figure that out a little bit. People want to do that anyway. And so you can see how it all comes together. And by about 2025 or so, we've got everything in place that we need to do the mission. So I think this is an approach that would build toward a permanent human presence on Mars. I think it's a kinder, gentler approach that if someone wanted to come home, they could, or if in the case of the reality show, they got put it off. They don't just have to go to Phobos or something. The major hurdle of entry, descent, and landing is addressed with this, and it fits within the sort of the structure of what's being referred to as the flexible exploration scenario. Chris mentioned the primitive bodies or the near-Earth asteroids. You could certainly use that as a demo mission for this approach too. Fly out there. I thought it was pretty neat that he showed the Orion sitting there next to it. We worked on the NEAR program, and I can remember talking to the guys at APL. They crept up on it. Farquhar was the scientist, and they kept getting closer and closer and studying all the weird gravity. And NEAR, I don't know if you all remember it, but it was not a lander, okay? It was a spacecraft, truly a spacecraft. It had solar rays that went out in a cruciform shape. And what they did, finally, they got down real close and they said, let's just see if we can go in and just touch it. And they actually did. They touched down on the body of the spacecraft and 2 of the solar panels. They landed near on the asteroid. So asteroids are cool that way. You don't have to do special landers. And finally, I'll just leave you with the thought that if we did this, we could break the lock that chemical propulsion and heavy lift has to be in the Holy Grail and develop a true spacefaring infrastructure. So thank you very much.
Bravo. Bravo.
I brought these too because in 1986 at the Mars conference, Pat Rawlings did these beautiful pictures, and there's the tug at Phobos, and there's a propellant rig set up. And these guys are making propellant on Phobos. Okay.
Bravo.
Oh yeah, questions. I'm sorry. Yes.
What kind of in-situ propellant production can you do that would work with a Hall thruster? What kind of ISP are you getting out of that with methane or oxygen or whatever?
Well, the Hall thruster right now is xenon, and the deal with the Hall thrusters are it's such a small amount of propellant that I go ahead and just bring it up. It's not the big driver. The big driver are the hydrogen, oxygen, methane. Those constituents for your chemical rockets, which would be used for your landers and your crew propulsion. So I wasn't really looking at doing ISRUs so much for that, although you could start to look at that as you evolve. You have to look at like trace elements in the Martian atmosphere and see. You can run these things on argon. They're typically like noble gas type thrusters. So any noble gas or krypton.
There's a fair amount of argon on Mars.
Yeah, so argon could work. And but I would see that as more of an evolutionary thing. I think initially you just bring the xenon up from Earth that you need. Thanks. Yes.
A couple of questions. When you had that large chart about all the NASA's going to Mars,
Yes.
Was that study predicated on using in-situ resource propellants?
That's a good question.
I don't think it was.
Yeah, I think that one. No, well, the one that had the big bump was the expedition, right? So you wouldn't do it in situ if
That's
you were
the
doing
problem.
that. Right.
That's
now,
the problem that ISRUs.
But mine that I compared to, the design reference mission, did look at in situ, and it also had, I forgot to mention that, it had nuclear thermal rockets for transportation.